So we jump now to Chapter 5 for just a brief bit, because some of the stuff they do in Chapter 5 is really stuff that we want to do now. Multiplying binomials is a subset of what we've been doing. We've been multiplying polynomials. We introduced the idea of FOIL, and we're going to expand on it. FOIL is an acronym that stands for first, outer, inner, and last. So basically what that means is that if I have two binomials, we're going to do something like this, maybe x plus y and a plus b, that the order that you can multiply them in is to go first, then we look at the outer ones, outer, then these we can call inner, and then finally we have the lasts. Like we said last time, it's a way to make sure that you multiply every term in one binomial by every term in the other one. You can always use the distributive property like we did, but let's watch how this works in some of the examples. First, a times a is a to the second power. Outer, a times negative b is negative ab. Inner, 2b times a is positive 2ab. And last, 2b times negative b is negative b squared. Finally, we're going to add the middle terms together because those are like terms. And oftentimes, when you're multiplying multiplying binomials together, the two middle ones are like terms. And we call these, and this is actually really important to know, we call these middle terms. I'm going to call them middle terms quite a bit. So we've got a squared plus ab minus b squared. Next, we have binomials that are not in descending order. They're actually in ascending order. How do I know that? Because it starts with a 5, and then the k is in the second term. So watch what happens when we multiply them. 25, outer is negative 20k, inner is negative 20k, and the last is positive 16k to the second power. When you add your middle terms, you get 25 minus 40k plus 16k to the second power. And that final trinomial is now in ascending order, just like the original ones were. Number 3, I have first 3x to the fourth, outer 2x to the third, inner negative 12x to the third, and last negative 8x to the second. Or 3x to the fourth, see positive 2 minus 12 is negative 10, negative 10x to the third, minus 8x to the second. This next one, now the two binomials are kind of different from each other. Y to the fourth times 3x squared is 3x squared y to the fourth. That would be my first. Outer, positive 2x y to the fourth. Inner is, that'd be negative 9 x squared y to the second. And last is negative 6xy squared. That was important to follow our first, outer, inner, last because of the coefficients and making sure that we have the correct coefficients. Now, if I look over this, I don't see any like terms. There's a little bit of a mix and match going with descending, ascending order, so we're really not going to worry about that. We're just going to keep it in the order we multiplied it in. So that's done. Can't really add anything and can't simplify that. Move around to the back of the first page. We have x to the third times 4x, which is 4x to the fourth. Outer is plus x to the third. Oh, forgot the 5. 5x to the third y. Then minus 24xy. Then minus 30 y to the second power. Not x, but y to the second power. No like terms there, so again, this is done. Number 6. Doesn't matter which order we multiply things in. To make things easier, I'm going to multiply these two together the way they are now, keeping the 2 off to the one side. So I get 4x to the second plus x minus 12x, then minus 3. Now, I'm going to follow the order of operations before distributing and simplify within the parentheses. 2 times 4x to the second minus 11x and minus 3. Distribute the 2 and I get 8x to the second minus 22x minus a 6. For the next one, I'm going to do the same thing. I'm going to keep the y off to the side and FOIL the other 2. 2y to the second plus 8y minus 1y, or just minus y, minus 4. Do another simplification step. 2y to the second plus 7y minus 4. And then I'm going to multiply the y in. So it's going to be 2y to the third plus 7y to the second minus 4y. Number 8. Okay. 2 times 2 is 4. X to the n times x to the n is x to the n plus n, or x to the 2n. Remember, when you multiply the same base, like these two here, you add the exponents to get x to the 2n. Then we have plus, if I do the outers, I have 2x to the n, y to the n. We keep them like that because they can't multiply together. Then I have minus 2x to the n, y to the n. And finally, negative y to the n plus n is 2n. Look at things that you can add and subtract. The middle two terms are like terms, and they are opposites, so they're going to cancel. I end up with 4x to the 2n minus y to the 2n. Next, I take a look at number 9. We also have variables in the exponent there. 3 times 5 is 15. X to the 2n times x to the 2n is x to the 4n. Outer, 18, x to the 2n, y to the n. Inner, negative 20, x to the 2n, y to the n. And last, negative 24, y to the n plus n is y to the 2n. The middle two terms, once again, are like terms. They can add 15x to the fourth minus 2x to the 2n, y to the n, then minus 24y to the 2n. That's it. No more like terms. Number 10 is a solve. We're going to simplify the left and simplify the right. So if we multiply the left side out, I get x squared minus 3n, or 3x, minus 2x, and plus 6. Then I'm going to have x squared plus 3x minus 7x minus 21. Simplify, x squared minus 5x plus 6, and x squared minus 4x minus 21. If we subtract x squared from both sides, I'm left with negative 5x plus 6 equals negative 4x minus 21. We can add 4x to both sides. I have negative x plus 6 equals negative 21. Subtract 6 from both sides, and I get negative x. Let's put bar areas there. Negative x is equal to negative 27, or x is equal to positive 27. Put that in braces because we are solving. We always put our solves in set notation. Number 11. Let's switch colors. Go green. Okay. This is a little tricky because of this thing here. Now, I'm going to write this out completely once before I worry about what to do here. I'm going to go n plus 3 parentheses 2n plus 3 parentheses equals n plus 2 squared is really n plus 2 times n plus 2. And n minus 5 squared is n minus 5 times n minus 5. Okay, that's a little weird, but not really. We cannot distribute a square across plus or minus. I just know this means we have to multiply it by itself. We talked about that before when we were multiplying binomials. So let's multiply this out. 2n squared plus 3n plus 6n plus 9 equals n squared plus, this would be 2n plus 2n plus 4 plus, and then this last one would be n squared minus 5n, another minus 5n, and plus 25. simplify the left and simplify the right. I have 2n squared plus 9n plus 9. Then I have, see, n squared. We have 2n squared. I have a 2n, a 2n, a negative 5n, and a negative 5n. 2 plus 2 is 5. 2 plus 2 is 4. 4 minus 10 is negative 6. So I have negative 6n. And then the 4 plus 25 is plus 29. Well, the 2n squareds are going to drop out. And if I add 6n to both sides, I get 15n plus 9 is equal to 29. Let's move it up here. Subtract 9 from both sides. I get 15n is equal to 20. Divide by 15, and I get n is equal to 20 over 15, which simplifies to 4 over 3. And there's your solution. For this next one, I want you to star this and revisit this on this video if you need to, because you're going to see a problem like this in homework. This is not terribly bad. You just have to know what it's asking. It wants to know what P, Q, and R are, and this gives you enough information to do that. The entire chapter is on FOIL, so we probably are going to have to FOIL those. 3p x squared plus, then I have pqx plus 6x plus 2q equals rx squared plus x minus 2. Okay, this is a little jumbled mess until we look at it a little differently. I'm going to say that this term here and this term here have to be equal to each other. I'm going to also say that these two and this one have to be equal. And then finally this one, which may be hard to see with that highlight. That's a little better. This one and this one have to be equal. Now why am I saying that? Because these terms in yellow are the ones that are the x squareds. These terms in blue are the ones that are the x's. And the ones that are not, or in green, are the ones that are the constants. They don't have an x. So I could say constant and constant. So what I'm going to do is I'm going to piece this apart into 3 different areas. Let's look at the x squareds. I know with the x squareds, I want the coefficients of the x squared terms to be equal to each other. So what that means is that 3p x squared has to be equal to rx squared. Well, if we look at that, that really just means that 3p has to equal r. Hold that thought for a second. Let's kind of circle that and kind of get back to there. Okay, let's go to the other ones. Let's go to the middle one here. I know that the ones in blue, those are the x squareds. Or sorry, not the x squareds, those are the x's. And then if I kind of write those out, pqx plus 6x has to be equal to x. Well, let's look at just the coefficients and ignore the x's. That means that pq plus 6 equals 1. I actually just dropped all the x's from those. That means that PQ has to be equal to negative 5 if I subtracted 6 from both sides. We're going to circle that one and come back to that. Finally, if I look at the green ones, the ones that are the constant terms, I know that 2Q has to equal negative 2. There are no x's to drop out of that. Well, this tells me what q is. Q has to be equal to negative 1. I'm going to box that. That's the solution for q. We're going to take that and I'm going to backtrack and go right there. If p times q is negative 5 and q is negative 1, that means that p times negative 1 is negative 5, which means that p is 5. I'm going to box that in right here, and I'm going to take that and put it right back there. That would mean that 3 times 5 is equal to r, or r is equal to 15. Now we have p, q, and r. Typically, if I'm going to set that and just say what they're or kind of express that in solution notation, what I would do is I'd put them in order. P is 5, q is negative 1, and r is 15. I put them like in ordered triple, not in ordered pair. But it's enough to just say R equals P equals Q equals. I just kind of like that notation too. Okay, we're going to practice right now a very specific kind of foiling called dots, difference of two squares. Whenever we multiply a difference of two squares, it says what happens to the middle term. Well, watch this. If I go first is y squared, outer is plus 6y, inner is negative 6y, and last is negative 36. My middle terms are opposites and they drop out. Whoa. That means it's just y squared minus 36. Let's go back up here. What happens to the middle of the terms? That should be an S there. We can say they drop out. Why is it called difference of two squares? Because what we have right here is a difference of two squares. That's the result. How do we know we're going to get that? Difference of two squares occurs when multiplying two conjugates. What are conjugates? Conjugates are binomials, two-term polynomials, binomials that differ in the middle sign. What does that mean? This is really easy. Just stick with me here for a second. That means that if I multiply something that looks like this, 2x plus y and 2x minus y, those are conjugates. They're not opposites. They're called conjugates. I am going to ask you for this word tomorrow in class. That is going to be one of the first things I ask you. What are two conjugates, or what are conjugates? And I want you to tell me they are binomials that differ in the middle sign. Think of all the words you have to know now. You have to know what binomials mean. You have to know that differ means that they're different. Middle sign means plus or minus. Okay, let's go down to number 14. When you multiply binomials that differ in the middle sign, you don't really have to worry about the outer and inner. All we have to do is first 4y to the 6th, and then last minus 49. Because the outer and the inners would have canceled each other out, negative 14y cubed and positive 14y cubed. That's done, and these are super fast to multiply. Let's try multiplying the first here, 9x squared, last, negative 16y squared. You may say, how is this different? Or this is really different. It's not different, we're just skipping the steps of doing the outer and the inner, because again, they would cancel each other out. 16, these are binomials that differ in a single sign. X squared, y squared would be my first, and then minus 64z to the second, that's the last. Please note that whenever we have difference of two squares as a result, whenever we do this, it's always minus in the middle. It will never not be minus. Let's go with number 17. Ooh, the last one. Okay, multiply these two. Let's keep the negative 3x off to the side, and I get x to the 4th minus 36. And now let's distribute. Negative 3x to the 5th plus 36 times 3 is 108. And you're done.